Alright, let's talk about how we organized the code behind our smart healthcare management system. We designed the project using a layered architecture with three core layers. So one is controller layer, the second one is service layer, and the third one is repository layer. So control layer handles API requests and passes them to the service layer, and the service layer contains the main business logic, and the third repository layer manages data access and communication with the database. So now let me break down the main folders in our project structure. So the first one is config. This contains all system configuration files including Swagger setup, database configs, security configs, and any other application wide settings. So the second one is controller folder. So here we define the API endpoints which handle incoming HTTP requests and send responses back to the clients actually. And the third one is DTO. This is actually data transfer objects. So in this folder, these classes shape the data we send in requests and responses, keeping them clean, structured, and deoccupied from the database entities. And then the exception folder. This folder handles the application's error management. It's where we define custom exceptions. And then the mapper folder. This folder contains classes that helps us map or convert between entities, DTOs, and responses, keeping the transformation logic separate. And then the model folder. This holds our entity classes. This represent the databases tables like doctor, patient, health profile, appointment. And then the repository folder. This is the data access layer where we define interfaces to interact with the databases, usually using Spring Data JPA. And then the response folder. This defines standardized API response classes so we can return consistent and clear messages to the client, whether it's a success or it's an error. And then the service folder. Here is where we put all our business logic. The services call the repository layer and handle the core functionality of the system. And then the Docker file. This file contains instructions to containerize the application so we can easily deploy it anywhere with Docker. We also follow some important design patterns. So the first one is the service layer pattern to separate the business logic from request handling. The second one is the repository pattern to isolate database operation. And the third one is DTO pattern to keep our API data clean and secure. And now I will handle it over to Noyon, who will walk you through some real code examples and show you how all these pieces work together in practice. Thank you.
So, okay, now I'm going to walk you through some core architectural pattern of our project. There are some controller section, DTO section, and the service layer. And in controller, in appointment controller, we can see that we have some annotation called REST controller and the request mapping controller that helps to create our HTTP endpoints. And here we have used the post mapping, gate mapping, port mapping, and delete mapping. And after that, in service layer, first we have used auto word, but auto word is detected as code smell by Sonar Cloud. So we have used constructor injection here, and we can see that in service layer we have had appointment and appointment get all appointments method, and after that get appointments by ID, update appointments and delete appointments. And here we have used another method called validation appointment create detail, where we have checked that the date is not null and the date is whether today's or for future. And after that we have checked that time. If the time is invalid, then we have given a message that appointment time must not be null. If in detail section we have created the appointment create detail and created the appointment detail, it is created, or detail section is created so that the user can see only the information that I want to see, and no internal information cannot be accessed by the user. And here the mapper section that helps us to map to create appointment information to retrieve and the information to entity. So exchange the information in this. Thank you for listening, and other parts will be described by Six Sabi. Thank you.
Thanks, Nan. Let's talk about testing now. So we used JUnit 5 and Mockito for writing unit tests. Let's look at the code of the appointment controller test to understand the unit tests properly. So this is the code of the appointment controller test, and by looking at it, it's clear that we have tested every CRUD operation. So there's method for test add appointment, test get appointments, test appointment by ID, test update appointment, test delete appointment. And one important thing is each test follows the arrange, act, assert pattern. And essentially what we are doing is we are mocking the service layer, isolating controller logic for precise verification. And we did this thing for every component in our system. And on top of that, we maintain custom API response structure using a generic custom response wrapper. So this is the code of the custom response wrapper, and yeah, this made both success and error responses consistent across the system. And all these practices were aimed at writing clean, understandable, and maintainable code. So yeah, this is it for the testing part, and let's move on to the tools, technologies, and deployment part. So thank you, everyone.